Hi Calc, this is Professor Wieland and we're going to start our calculus class, so welcome aboard. So the very beginning of calculus class is limits, and limits is more of a conceptual idea. A limit is basically asking where are you approaching or where are you going. And I'll explain that in a little more detail as we go through this. So this first chapter is going to cover that concept of limits. So limits can be done analytically. So you can have like an equation. Limits can be done graphically. So you can analyze a picture. And another way you could do a limit is to study a chart. Okay? So when we start this course, we're going to start with something called a two-sided limit, which means that we're going to approach from both sides. So this here is the abbreviation for limit, and this is asking what is the limit of this function as x approaches 2. So the concept is as x goes to 2 from both the right and the left, what is the height approaching? So as I come in from the right, what is the height approaching? As I come in from the left side, what is the height approaching? Okay, that's the concept. It's really important that you understand that I'm using the word approaching, because this is not an intermediate or pre-calculus concept where you like are evaluating. Evaluating is a static concept. It means you're trying to find an exact spot, where a limit is like, well, where are you heading? So let's say you have a favorite restaurant you like to eat at, and so you say to your friend, oh, I'm going to go to Charlie's restaurant. When you get there, Charlie's restaurant might actually be missing, but the limit means you were going to Charlie's restaurant. Whether it's there or not is indifferent. Okay, so you've got to keep in mind that you have to see this more like a movie versus an evaluation. Okay? All right. So just real briefly, and we'll go through all the parts. And this is just real brief because I'm not actually doing it yet. But if you have, if you're doing it analytically, it's actually like a plug and chug type of problem. If you're doing it graphically, then you just sort of have to study the spot that you're looking at. And if you're doing a chart, you have to approach from both sides numerically what you're approaching. Okay? We'll go through that stuff, so don't stress out about it. So before I start, I'm going to start with doing the graphs with you. But before I start, it's really important that you understand that sometimes that there is no answer. Okay? So 3 ways that the two-sided limit fails to exist, okay? The two-sided limit will fail to exist if, as you come in from the left and you come in from the right, the function doesn't approach the same value, okay? So let's pretend this is your friend and this is you. This is where you're going, and this is where your friend is going, okay? This is technically unbounded. Okay, so it means it doesn't stop going anywhere, right? You're not actually going to a specific destination because it's unbounded. It never stops going to infinity. So the first case that where a limit fails to exist is if as you approach some value, so as your x value approaches some value, f of x is unbounded, right? Meaning it's going to positive or negative infinity. So as your x value goes to some specific value, the y function, the height becomes unbounded, because that's not a specific location in space. You can't say, hey, let's meet up at infinity. That's not approaching a specific location, okay? So if you're going to positive or negative infinity, there is no answer. Now, by the way, if there is no answer, which are the cases we're going over now, you write DNE. And DNE is shorthand for does not exist. Okay, this is just shorthand for does not exist. All right, so that's the first case where the two-sided limit fails because the function becomes unbounded at the point that you're looking at. Okay, this function is only unbounded at 0, this particular one. It has a limit everywhere else. Okay, how about here? Can you picture you and your friend? You're going to this destination and your friend is going to this destination, so you're not going to meet up. Both sides have to approach the same value. Okay, this one's approaching, whatever this is, looks like a -1, and this is approaching a 1. So again, as x approaches a particular value, the two-sided limit fails to exist if at that point the function has a gap. If the function has a gap at that point, there's no limit here. There's a limit everywhere else, but not at x equals to 0, because the heights aren't going to the same place. They both have to be going to 1, or they both have to be going to -1, but they cannot be going to different heights. All right, now this one's a little harder to see conceptually because it's hard to graph this concept. But what's happening here as we get towards the origin is that the function is increasing in oscillation. So it's like it's speeding up. It's rapidly speeding up as we go. It's increasing in oscillations as we go towards 0. So it's sort of like, think about there's like a particular target you're trying to hit, but it keeps jumping in and out of the target. And it's sort of like that concept. It's increasing and it's bouncing, so it's not actually approaching something. It's just bouncing all over the place. So the last case, what's happening is as you approach a particular value, the function itself is increasing in oscillations. Okay, now it has to be increasing. If it's just neutral oscillations, we can find the limit. If it's decreasing oscillations, we can find the limit. If it's this idea that it's increasing in oscillations, then it does not have a two-sided limit. That's the problem. Okay, I'm going to end this first video here, and I'm going to remind you of this information because what I want to do is we're actually going to solve some of these, and I want you to think about what those answers might be, okay? But this one, I just don't want the videos too long. So I need you to remember that the two-sided limit fails to exist if at the point you're analyzing is unbounded, or it has a gap, or it's increasing in oscillations. If it's any of these three cases, the answer is DNE. All other cases actually have an answer, okay? So you need to memorize these three scenarios. Okay, gang, I'll pick up in the next video. Bye-bye.